Year 10s. So now that the coronavirus has hit and you're all doing work from home, this lesson is on scientific notation. So as per the course outline, this is exercise 3G. So I've written down some notes. I want you to copy it down and press pause on the computer when you get to one screen. So copy the notes down, just like we would in class. Alright, so hopefully you've had a chance to copy the notes down. Now I'm going to explain the work exactly like I do in class, and then I'll do some examples, and then you have to do the exercise just from the course outline, and it'll be on Link as well. Alright, and this video will be on YouTube, so all you have to do, I'll send you the link, and all you have to do is click on the YouTube, the public video, so everyone's got access to it. Alrighty, so scientific notation. Scientific notation is used for really big or really small numbers. So for instance, if we said the size of planets, the distance in between Earth and Mars, it's a really big number, so we don't want to write out a number that's got like 15 digits, so what we use scientific notation. Same thing is if we said what's the size of an atom in microscopic terms, so we use a really, really small number. So instead of writing 0.0000, you might have 15 zeros, we use something called scientific notation. And apparently you've done this last year as well in Year 9. So, this is an example of scientific notation. 3.5 times by 10 to the power of 7. What that means is, every time you multiply a number by the power of 10, you move remember from place value from Year 7, you move the decimal place one spot to the right. The number gets bigger by one power of 10. So in this case, it's getting bigger by 7 powers of 10. So we'll move this decimal place 7 spots to the right, but I'll get to that in a second. So there's big numbers and there's small numbers with scientific notation. For big numbers, we use the power of 10 and we move the decimal place a certain number of spots to the right. So you're jumping these digits to the right, depending on how big the scientific number is. So you can read the notes there. I'll show you some examples. So here's a big number. It's 75 million. So instead of having to write all those zeros all the time, we generally write scientific notation with one digit and then the decimal point. So in this case, we write the first digit is 7, then a decimal point, and then we put the 5 there. Can you see we've got one digit and then a decimal point. We can have as many digits after that you want that are non-zeros, but in this case we've got 7.5. Now, what we do, it's a big number, so we're going to write times by 10 to the power of something. So we have to work out how many times are we jumping or moving this decimal place to the right. So we've put the decimal point in between the 7 and the 5 there. So that's where the decimal point is. We need to count how many times we jump to the right. So there's 1, 2, 3, 4, 5, 6, 7. So we make it times by 10 to the power of 7. And what you should do is just recount them and make sure that it matches up. So 7.5, yep, it's 7 to the right. So we know that number. That's a number, it's a basic numeral. That's a number in scientific notation. Hopefully everyone's okay with that? Excellent. Let's do another example. Here we've got 900,000. So we write down the first digit is a 9. Then we put the decimal point. We generally don't leave it like that, so we'll put another 0 at the end. So it's 9.0. Times by 10 to the power of something. So we put our decimal point here after the 9. We move it 1, 2, 3, 4, 5 spots to the right. So we put down a power of 5 there. And that's how we turn a big number into scientific notation. Okay, and now we also need to be able to do the opposite. So we need to turn a scientific notation, a big number, into a basic numeral. So here we've got 4.2 times by 10 to the power of 4. So it's the same process but in reverse. So this time we're going to move the decimal point 4 spots to the right, but there's our decimal points. The first one to the right jumps to 2. That's 1. We've jumped it once. We have to jump another 3. There's nothing to jump, so we have to add zeros. So we put down a 4 and then a 2. So the 2 is the first one we jumped. We have to jump another 3. So 1, 2, 3, and put a comma in. Once you've written your number as a basic numeral, again, check. So if we put the decimal point there, 4 spots, 1, 2, 3, 4, and that's where the decimal point is at the end of every number, isn't it? So we know that we're correct. And let's try the next one. Here we've got 2 digits after the decimal point, it doesn't matter. So, and it's 10 to the power of 8. So we're going to jump 8 spots to the right. So 2, 8, 1. So we've already jumped 2 spots to get past those digits that are there. So that's 2. So how many more do we need to jump to the right? We need another 6 because there's 8 in total. So we add 6 zeros. 1, 2, 3, 4, 5, 6. So that number in scientific notation is that number as a basic numeral. And of course you should put commas in to make it a bit easier to understand. So that number is 281 million. So now we've written it from big numbers, from basic numerals to scientific notation, and also back the other way. So if you need to have a pause the video now, that's fine. Otherwise, I'm going to keep on going with small numbers. So it's the same concept. Maths is all about the same concept, but this time they're very small numbers, and our power is negative. So the difference here is that we're jumping to the left instead of the right. So to make the numbers smaller, we're moving the decimal point to the left. Okay, so here we have a basic numeral again, 0.000052. It can get a bit annoying when you have to write so many zeros all the time. So to write this in scientific notation, again we start with the first digit. So we put the digit there, then we put our decimal point, and we've also got a 2 there. So we put down the decimal point in between these two. So I like to mess this number up a bit, and that's where my decimal point's going. Now we write times by 10 to the power of something. But this time, because we're moving to the left, it's to the power of negative something. So we have to count again. So it's 1, 2, 3, 4, 5 to get to where the decimal point is. So it's times by 10 to the power of negative 5. And again, check your work. So if the decimal point's there, 1, 2, 3, 4, 5, yeah, it's the right number. Sometimes people make mistakes by they move the decimal point. They might put it there at the end, or they might jump. Just have to count carefully. So the next one, to another example, the decimal point generally goes in after 1 digit, so it becomes 3.84. See, the decimal point goes there. Times by 10 to the power of, we count 1, 2, 3, 4, and it's going back smaller, so it's to the power of negative 4. So just remember it's a negative there. Excellent. Hopefully you're okay so far. And then the last little bit, we've got scientific notation. And this is a small number. See how it's to the power of negative 5. This one's a little bit trickier. So this time we've got 2.56. This time we have to move the decimal point 5 spots, but to the left. So the first one can jump that 2. That's 1 gone. But then we have to jump another 4. There's nothing to jump here. So what we have to do is add zeros. So you can add as many zeros as you like, but then we just have to be careful where we put our decimal point. So the first one jumps to 2, and then that's 2, 3, 4, 5. So our decimal point goes in there. So I didn't need that 0 there at the end. So now just make sure you've done it correctly. So there's the decimal point, 1, 2, 3, 4, 5. So our answer is 0.0000256. And I'll get rid of the decimal point from there, because you can't have 2 decimals in a number. That was just so I can work out where the decimal point moves to. And generally speaking, some people like to write the number as 0.000. You generally have a 0 at the front. It's just maths convention. So we have 0. Then it's 4 zeros, 256. And again, we'll do it the same one for this one. You might need a bit of space. So I'm going to do it here. So it's 6.4. And it's going back 7 decimal places. So it's going to jump 7 to the left. So what do we have to do? Put lots of zeros. So I did it on another line, otherwise I'd probably run into this. Doesn't matter how many zeros you put, for now, we'll rub them out in a minute. So we're going to move 7 spots to the left. 1, 2, 3, 4, 5, 6, 7. And there's our decimal point. Get rid of that 0 that we didn't need. And get rid of that one there. So our number is 0.00256. once you understand this, I want you to practice a couple of examples from your textbook, and then we're going to do 3G from the course outline, questions 1 to 9. So practice that, check your answers in the back of the book, and if you have any problems, please make sure you email me, or we'll do a group chat, or whatever we decide as a class. You can also use CAS, which I'll show you in a couple of minutes. Okay, thanks kids, have fun at home. Bye. Shh. Alright, so now that you've learned how to do scientific notation, I want you guys to do a practice question. So write these down in your notebook, please, exactly as I have there, and I want you to answer them. So write them down, pause your video, and in about 5 seconds, I'll work them out for you, and you can check your answers. So pause it now. Good job. Okay. Now you've attempted these questions. So write this one in scientific notation. So remember the decimal point goes after the first digit, so it's 4.78. Because it's a big number, we know that it's times by 10 to the power of something, a positive number. And mess this number up if you want, I don't care. 1, 2, 3, 4, 5. We jump 5 spots to the right, so you put a 5 there. Good job. Give yourself a tick or a cross, hopefully a tick. Next one. There's a digit, so we write down 5.2. We write down times by 10 to the power of. Because it's a small number, it's to the power of negative. Don't forget to put negative there, because we're jumping backwards. There's our decimal point. 1, 2, 3, 4, 5, 6. So it's times by 5.2 times by 10 to the power of -6. Good job. Hopefully you got that right as well. Now, write it as a basic numeral. There's our number. It's a big number because it's to the power of 6. 10 to the power of 6. So we write down 8, 1, 5. So we've already jumped 2 decimal places to get 815. So we need another 4. So we add 4 zeros. 1, 2, 3, 4. There's our answer. Put commas in. Every 3 digits, put a comma in. So now we can see the number is 8,150,000. Excellent job, guys. And the last one, I put a new line here because we need to go backwards 5 spots. So we've got 314, but remember the decimal point's after the 3. So the first jump is a 3, we need another 4. So we add lots of zeros. Doesn't matter how many zeros you add, because we'll put the decimal point in a minute. It's 1, 2, 3, 4, 5. So the decimal point goes in there. So add the perfect amount, 0.0000314. So hopefully you give yourself a score out of 4. Hopefully you got 4 out of 4. And now you're ready to do the exercise 3G 1 to 9 on page 221. Good job, guys. I'll see you soon.